Another sampling technique that is very common to use is called a stratified random sampling. Now, stratified random samplings can help reduce potential for bias, probably better than any other sampling technique that we will be working with. However, it can also be the most difficult to do at times, the most time-consuming, and the most expensive. Here's a basic idea. First thing you're going to do is you're going to break up your population. I'll say divide population into strata. Strata is just another name for groups. Now these groups aren't just arbitrary, they're very special. The groups are similar within. Homogeneous is typically the word that's used. And they're different between. Heterogeneous is typically the term that's used. Now, as an example, if you're taking a political poll and you know that in a particular area of the country, say 62% are conservative, then you would want to break up the population into 62%, say Republicans, and then the rest being Democrats. And for sake of conversation, let's assume we only have Democrats and Republicans to deal with. Let's make it simple for right now. Then I would go ahead and take a simple random sample, or possibly a systematic 1 in K, within each strata. So let's just make numbers really, really easy just for the sake of conversation here. Let's just say that I'm sticking with the Democrats-Republicans thing. So let's just say that Republicans are known to make up 62% of this population I'm working with. That means the Dems are at, well, 38%. And let's just say that I know that I can take a sample N of, we're going to make life really easy, say 100. Well, how many do I get of each? Well, I would take N times 0.62. That would give me, in this case, 62. So N sub R, the sample size for the Republicans, would be 62. And then N times 0.38, that equals 38. So N sub D, the sample size for the Democrats, would be 38. Now, by doing this, I'm going to ensure that I don't have clumping. If I have 62% Republicans in this population, I don't want to risk the possibility of getting like 72 or 73 or 80% Republicans. That would just well overrepresent the Republicans and would skew my results. I wouldn't get an accurate picture of what's going on. Likewise, I wouldn't want to represent the Republicans. If the Democrats are actually 38% in this area, I don't want to be getting 50% Democrats. Then again, I'm not going to get an accurate picture of what's going on. So these numbers that I chose are pretty straightforward. Let's just calculate again, just for the heck of it, just play with something real quick. Let's say I have 3 different groups. And as an example, I know that group A makes up, I'll say, 32%. And then I know that group B makes up, say, 41%. And that leaves group C, which should be at 27%. And let's just say that my sample size that I'm able to take is 1,321. So how many do I take of each? Well, N sub A, the number from group A, will be 1,321 times 0.32, which is 422.72. I'm going to leave that decimal for right now. And then NB will be 1,321 times 0.41, which is, see, 541.61. Again, I'm going to leave that decimal for right now. And then group C is going to be 1,321 times 0.27, which is 356.67. Now, what we want to do is we want to use proper rounding. So what I'm really going to get for this one is 423. For this one, proper rounding would bring me to 542. And for this one, it would bring me to 357. Now, if I add these numbers up, I'm not going to get 1321. When you add that up, you're going to actually get 1322. Well, you need one more than you can get. Well, here's the deal. Figure it out. Either you can add one more, make sure that you can get 322, or if you're going to have to stay with 321, go to the biggest group, which was group B, and rather than getting 542, I would get 541. The reason being, taking one away from the biggest group would have a smaller impact than one away from the smaller group. Now here it's not so obvious because these are all 3 and 4 and 500s. But if you had a group here with, say, a fourth group, and this distribution is slightly different, that had a very small percentage, and you ended up with maybe only 13 from that group, pulling one away from that 13, percentage-wise, is a bigger percent of that sample. You want to try to avoid that. You want to have as minimal impact as you can. So now that I have these sample sizes, I would simply go to these groups that I've already broken up and take the sample. Now, one thing I want to go back to is I want to address this idea here about the homogeneous and heterogeneous. Now, these are similar within and different between. Well, if I'm talking about these political parties, Republicans, in terms of political events, think more alike. Democrats tend to think more alike. Republicans and Democrats tend to differ in their thinking. Hence, it makes sense to break them up into that group. When we talk about them being similar and different, it's similar and different with respect to whatever it is that we're actually measuring. Age groups, you may want to stratify by age. People in their 50s and 60s are thinking a lot more about their retirement than somebody typically in their 20s or 30s. So if we're doing a survey, we're asking about their opinion on a measure that's going on a ballot that could have an impact on retirement. Well, the folks getting closer to retirement are going to have a stronger opinion about it, probably. So it may make sense to break it up and stratify so that we don't misread the public by getting a over or under representative group of that older group in the 50s and 60s.